All right, let's dive right in. Today we're talking about the real, fundamental building blocks of almost all modern software, classes and objects. Think of them as the DNA for pretty much every app on your phone. So, have you ever wondered how an app like Instagram or TikTok can juggle millions of different user profiles? I mean, every single one has its own photos, its own followers, its own bio. You think it would be impossibly complex, right? Well, the secret is that it all starts with one single, reusable blueprint. And that blueprint, that's what we call a class. Now, a class isn't the thing itself. It's the plan for the thing. It's what lays out all the potential characteristics, we call those properties, and all the possible actions it can take, which we call methods or functions. Okay, this slide makes it super clear. Over on the left, you've got the house class. That's the generic blueprint. It just says that a house can have a color and a number of windows. But on the right, you see a real, actual object, my house, that was built from that blueprint. It has a specific color, white, and exactly 2 windows. See the difference? The class is the idea, the object is the reality.
So, how do we get from that abstract blueprint to a real, tangible object that we can actually use? Well, that's where the whole construction process kicks in.
It turns out every class has a special set of instructions baked right in, called a constructor. When your code says, hey, I need a new house, the constructor is the part of the blueprint that gets followed to actually build it, piece by piece.
And this, right here, is a super important detail about those instructions. On the left, that value x is just a temporary piece of information. It's used during the construction, and then it's just thrown away. That's why you get an error if you try to ask for it later. But on the right, by adding that little word val, you're telling the blueprint, hey, this y value isn't just for building. I want you to keep it as a permanent property of the house. It's a tiny bit of code that makes a huge difference.
Okay, so once your object is built, it really has 2 main parts. It's got properties, which is its data. You use val for things that never change, kind of like writing in permanent marker, and var for things that can change, like writing on a whiteboard. And then it has member functions, which are all the actions it can do. You get to both of them using that simple dot, like person.name or house.updateColor. But here's where things get really clever. Properties don't have to be just simple storage bins for data. Let's imagine your blueprint stores a first name and a last name, but what you really need over and over again is the full name. Well, check this out. You can create a computed property with a custom getter. This full name property doesn't actually store anything itself. Instead, it's like a tiny little machine. Every single time you ask for the full name, it just runs this little piece of code, grabs the latest first name and last name, and sticks them together for you on the fly. It's super efficient and guarantees the full name is always up to date.
Okay, so having one blueprint is great, but in the real world, you almost always need variations on a theme. And that leads us to this idea of creating a whole family of related classes. Let's jump back to our house blueprint. It's a great starting point for sure, but what if you need to design more specialized houses? You know, like a cozy, single-story bungalow or a huge, sprawling mansion. They're both definitely houses. They share core things like having walls and a roof, but they also have their own unique features.
This is exactly where inheritance comes into play. If you want to create a specialized version, what we call a subclass, here's the recipe. First, you have to explicitly mark the original blueprint as open, basically giving permission for it to be modified. Then you use a colon to say, hey, this new class I'm making is based on that old one. And finally, you use the override keyword to provide your new, specialized versions of its functions.
But what if you don't want to share a whole blueprint, but just a set of capabilities? That's an interface. Think of it as a contract. It says, look, I don't care how you do it, but any class that signs this contract must have the ability to do things like fly or calculate area. And here's the kicker. A class can only inherit from one parent, but it can sign as many of these interface contracts as it wants.
And then, sitting right in the middle of those 2 ideas, you have the abstract class. I like to think of it as a partial or unfinished blueprint. It might have some parts totally drawn out and ready to go, but other parts are intentionally left blank, marked as abstract. You can't actually build a house from this unfinished plan. Another class has to come along, inherit from it, and fill in all the missing details first.
So how in the world do you choose? Well, this table makes it pretty straightforward. If you need to share some common data or state between your classes, look here. An interface can't do that, so you'll need an abstract or an open class. If you need a class to adopt behaviors from a bunch of different sources, an interface is your only option. And if you need to force your subclasses to provide their own custom implementation of something, an interface or an abstract class will get the job done.
All right, now for some of the really fun stuff. Let's look at some specialized tools and upgrades that Kotlin gives you to make your blueprints in your code way smarter and more efficient.
So here's a problem every developer runs into. What if you want to add some new functionality to a class that you didn't write? Maybe it's from a library and you literally can't change the source code. It's like you bought a whole neighborhood of houses and now you want to add a doorbell to every single one, but you're not allowed to edit the original blueprint. What do you do?
Well, the solution is this fantastic feature called an extension function. It basically lets you bolt on new methods to any existing class without ever touching its original code. And this example here is just mind-blowing. We are adding a new function called isOdd directly to Kotlin's built-in int number type. We're not changing the original int class at all, but from this point forward in our code, every single integer suddenly knows this new trick. It's incredibly powerful.
Now, speaking of powerful shortcuts, just look at the magic of a data class. On the left, you've got the standard way of making a class that just holds some data. You have to write all this boilerplate code yourself. But look at the right. Just by adding that one little word, data, the compiler automatically generates all of that stuff for you behind the scenes. It turns what could be dozens of lines of code into a single, clean, beautiful line.
And the toolbox has even more goodies. You've got enums, which are perfect for when a property can only be one of a few specific things, like the days of the week. You've got an object or a singleton, which is your go-to when you need to absolutely guarantee there is one and only one instance of something in your entire application. And pair and triple are just quick and dirty shortcuts, although honestly making your own named data class is usually a better idea.
Finally, once you've created all these amazing blueprints, how do you keep your project from turning into a total chaotic mess? Well, you need organization, and you need a little bit of security.
Your first tool for organization is packages. And honestly, the best way to think of them is like zoning districts in a city. You put all your user profile-related classes in one package, all your database classes in another, and so on. It just keeps related things together and stops you from accidentally giving two different things the same name.
And your second tool is all about controlling access or visibility. Just like a real house, some parts of your class should be public. That's like the front door. Anybody can see it. Other parts should be private. What happens inside the bedroom is nobody else's business. And some things can be protected, which is kind of like the family room. It's accessible to the immediate family, meaning the class and its direct children, but not to the general public. These are absolutely essential for writing safe and predictable code.
So there you have it. From that single, basic blueprint of a class, all the way up to an organized digital city built with packages and visibility modifiers, these are the fundamental tools that build our digital world. The whole concept is what lets us turn simple lines of code into the complex, amazing applications we use every day. So, I guess the only question left is, now that you have the blueprint, what are you going to build?